Hello everyone, very good evening one and all. Welcome to the most comprehensive preparation app for all exams, BYJU'S Exam Prep, and warm welcome to the series quick recap of computer networks in just 5 hours. Guys, we know computer networks, which is the very important subject, very independent subject, from which we can expect around 8 to 12 marks in any GATE exam, right? So from this computer networks subject, we will be learning 5 important, the most weightage topics, means the frequently asked topics. You see any year GATE paper, definitely you will find the questions from these 5 topics. So what are the 5 topics we are going to learn in this week? Today we will be learning about delays and error control. Okay, in today's session we will be recalling quickly with the questions about delays and error control, and tomorrow we will be discussing sliding window protocols. Definitely it is very important topic, frequently asked topic. And then we will discuss about IPv4 addressing, then TCP congestion control, and then application layer protocols. So dear friends, you see, and you just give me the comment, are these 5 are not the primary weightage topics of computer networks? We do have some other topics, yes, framing is there, bit stuffing is there, obviously we do have some other topics, definitely, but these 5 are the top 5 topics in computer networks, yes or no? Hi Anita, Anu. So in this week, let us stick to our computer network subject. Let us gain the maximum from these 5 topics. Let us try. So before I start the series, the session, let me introduce myself quickly. I am Satya with 15 plus years of teaching experience, mentored more than 35,000 students all over India in the GATE and PSU segments, and myself, I am a research scholar, qualified in GATE, qualified in UGC NET, qualified in SET, and also certified by Cisco. This is quick brief about me, dear friends. Now 5 tips to boost your score in the mock tests. This time you might be attempting the mock test, right? So how you can boost your score with 5 tips. Our expert Mr. Fanindra Sir, who has done his MTech from NIT Trichy, will be giving you the most important 5 tips in these 3 months how you can boost your score on 1st November at 8 PM. So try to attend this session without fail. Now guys, let us start the session. First of all, delay. What this delay means? It is another term for time. Okay, what the delays are? When we say network, the main purpose of network is communication. We wanted to send the data from one node to another node or source to destination. This is the main purpose. So what is the time taken for sending the data from one node to another node? That is what? The time. This time is comprising of 4 different time intervals. They are transmission delay, propagation delay, queuing delay, and processing delay. If I take the total time as T, this T is composition of summation of transmission delay, let me call it as a TT, transmission time. Propagation delay, let me call it as a TP. Queuing delay, TQ. And processing delay, let me call it as TPR. Okay, so what is this transmission delay, propagation delay and all? Let us understand, rather than reading the definitions, let us understand with an example. So here is an example which will make you understand about these delays very clearly, dear friends. Just understand this example, then all these 4 delays are clear for you. Hi Kaustubh, Divya, Devika, AB de Villiers, everyone. What? First of all, queuing delay. See, these are all the passengers waiting to board into the bus to travel to some place. In the same way, we will have so many packets to transmit to the destination, like every passenger, every packet. So every person here you assume as a packet. Okay, now as you are not the only passenger to travel in this bus, definitely there could be some waiting time for you to board the bus. But can you board the bus directly? No, you have to collect the ticket at the ticket counter, isn't it? So let us suppose this orange color person is our packet. This packet, to reach this ticket counter, certain waiting time will be there, right? So the time for any packet, I am taking this as my packet, you take the last one as your packet, or any packet. If you take the first one as packet, the waiting time might be 0. So in the worst case, if you take for any packet, the waiting time in the queue, why they are waiting in the queue? To collect the ticket. What is this ticket counter? This is the ticket counter. This is our node. This is our computer. This is our layer. So why this person is waiting? To reach the counter so that he can collect the ticket. Similarly, our packet should be processed by the node. Processing means what, sir? Packet is not forwarded directly, no? Your message, your data is not forwarded directly. It is added with some control fields, header, tailer. In that header, several fields will be there. So to add all those fields, some time will be required, right? So without control field, you alone cannot travel. So without collecting ticket, how you can't board the bus? In the same way. So the time taken by the packet waiting in the queue for waiting for node, that is called queuing delay. TQ or queuing delay is equal to waiting time in the queue. Now the person, the packet reached the ticket counter. At the ticket counter, certain time you spend, like you will give your money, you will give your preferences. I want that ticket, that seat, this seat, front row, last row, middle row, or window seat, aisle seat, and you will collect the change. They will see the availability, they will print the ticket. थोड़ा तो processing होता ना counter पे. Same way, the node takes some time for calculating the header, tailer, appending them, making ready for the transmission. So the time packet spend at the node, the time packet spent at the node. This is what we call as processing delay or TPR. Okay, fine. You did wait in the queue, you have collected your ticket. Now you should board the bus. You should board the bus. Assume you are having so many luggages with you, so many suitcases, so many bags with you. So you have to take all your luggage into the bus and board, isn't it? So you take some time to board it, isn't it? So the time to copy or load or push your data, your packet into the medium, into the channel, this is what you call as transmission time or transmission delay, TT. Now once all the passengers boarding is over, the bus starts its journey and reach the destination. The time to reach the destination, the traveling time, the journey time, this travel time, the time to reach the destination, this is what you call as propagation delay. Now clear for you what is TQ, what is queuing delay, what is processing delay, what is transmission delay and propagation delay? Everybody? Anita, Devika, Nishu, Kaustubh. Now it is clear for everyone what these 4 different times are? Please give some response. So this is the very simple example with which these 4 different times you can understand easily. So in this queuing delay, if you take, it will be generally in microseconds or nanoseconds. Processing delay, if you take, it would be in microseconds. Transmission delay, if you take, it will be in milliseconds, sometimes seconds. Propagation delay, generally it would be in seconds. Generally, it can be more or less. That means you understand, that means you please understand the queuing delay, processing delay are very, very less compared with the transmission delay and propagation delay. So actually T is summation of TQ, TPR, TT plus TP. But if I neglect TQ and TPR as they are very, very minute, then what would be the total time? Transmission delay plus propagation delay. Now everybody focus on these two, transmission delay, propagation delay. What transmission delay means? I said the time to copy your data, load your data into the medium, into the channel. On what factors it is dependent? Check it once. If you have more data to load, you take more time. Less data, less time. So the time to load, this transmission time, is directly proportional to the data you have, data size. And if you see, this is the bandwidth of the channel, this door, this way of the bus where you can board. If you see, this is very narrow, maybe one passenger can get in, can board at a time. If you assume I incorporate one more door here also, then 2 passengers can board at a time. So if the bandwidth is more, in less time you can load. If bandwidth is less, you take more time to load. That means the transmission time TT is directly proportional to your packet size and inversely proportional to bandwidth of the channel. है ना बेटा? Now, what is propagation delay? Journey time. It is the most famous formula. How do you calculate normal time? Yes, distance by speed, distance by velocity. How long you have to travel and at what speed you are traveling. It is directly proportional to distance, inversely proportional to velocity or speed. Here distance means what? The distance between you and the next node, or sender and the receiver, source and the destination. Here distance means how you people are connected, definitely through channel, right? Here bus is the carrier, road is the channel. Without road you can't travel, no? Without connection you can't communicate. So the medium, the channel, the cable length is what the distance. For that the carrier signal is like bus here. Getting the point? Everybody? So propagation delay TP is directly proportional to distance or length of the channel and inversely proportional to velocity or speed. So that is what listed here. Transmission delay is length of the packet or size of the packet divided by bandwidth, and propagation delay is distance by speed. Dear friends, when we are calculating the problems on this, many students do silly mistakes where in the unit conversions. Very important, dear friends. How we measure length or size of the packet? Maybe in bits or bytes. How the bandwidth is measured? Of course, if it is analog signal, we measure differently. But if it is a digital signal, definitely bits per second or bytes per second. So with this unit you can understand what is given and with these units you have to please understand and mind that you have to do proper conversion. Okay? And propagation delay, which is distance between sender and receiver, in the other way how you can call it as length of the channel. How do you measure the distance or length? Maybe in meters or kilometers. How do you measure speed? Meters per second or kilometers per second? So meters or kilometer gets cancelled and finally you will get the time in seconds, right? So guys, unit conversions are very important. Now when you take big networks, the distance between the nodes is long. So there, for big networks like wide area networks, if you take internet, WAN or very wide area network, there the length or the distance between the nodes is huge. So there transmission delay will be less, propagation delay will be more. But if you take small networks like local area networks or Bluetooth or PAN, there the distance between the nodes is very less, so transmission delay will be more than propagation delay, or maybe you can say equal. So if you take a LAN, assume this is the LAN, local area network, in a building, in a room, you observe the distance between the nodes is very less. But if you want to send the packet, let's say this node A wants to send the data to node X. They don't have direct connection. They don't have direct connection, right? So they will send, A will send to B, B will send to C, C will send to repeater. Like that, assume from like this, in this way the data is coming. In this way the data is coming. If so, A has to load the data has to travel till repeater, from repeater to repeater, loading, traveling, because guys, repeater is also a node. Node can be networking device or computer, remember. Okay, so at every node, transmission delay, propagation delay, transmission delay, propagation delay. So every node has to load, propagate, load, propagate. In this way, you just calculate, you just sum up all the transmission times and all the propagation times. Which will be more? Transmission time will be more. Traveling time is very less, propagation time, because the nodes are just nearby. Isn't it? We know length and propagation delay are directly proportional. So as the propagation delay is directly proportional to length, when the length is less, obviously propagation delay is less. So in small networks, we can take transmission delay will be greater or equal to propagation delay. Kaustubh, 1K small b means bits, kilobits, first thing. We have to take 1024 or 1000, that in the question we can assume 1K is approximately equal to 10 cube for the easy calculation purpose. But mostly that will be given in the question. In the question they will give 1K approximately equal to 10 cube or 1000. Okay, for computer networks questions we can approximate. Ethernet in syllabus, Nishu? Yes, it is in. It is in. All right. So guys, we have a local area network with different standards. There is a standard called IEEE 802.3, which is technically called as Ethernet, that follows CSMA CD technology. We will talk about this later, sometime later. So this particular network maintain the distance, packet size, propagation speed, bandwidth in such a way that at any point of time you see transmission delay will be greater than or equal to 2 times of propagation delay. So this will be applicable only in IEEE 802.3 or Ethernet or CSMA CD networks. So in the question, when you find this term, then only you are supposed to apply this relation. Got it? Now you look at the question. We have 2003 gate question here. A 2 kilometer long broadcast LAN has 10 raised to 7 bps bandwidth and uses a CSMA CD. Signal travels along the wire at certain speed. If so, what is the minimum packet size? फटाफट calculate कर लेना बेटा. As it is given CSMA by CD. So let me change the color. As it is given CSMA by CD, we can say transmission delay will be greater than or equal to 2 times of propagation delay, because it is given, this is using this technology. We know transmission delay is packet size by bandwidth. That is greater than or equal to 2 times of propagation delay is length divided by speed. We have got 3. We should find the other. Calculate. Let packet size be the calculating the wanted x. So x is equal, x should be greater than or equal to 2 into length is given 2 kilometers, speed is given 2 into 10 raised to 8 meters per second, bandwidth is given 10 raised to 7 bits per second. So guys, first when you are substituting, I always suggest please make a note of the units. Along with units you please substitute so that you don't forget anything. So per second got cancelled. It is in kilometer, it is in meter. So let us substitute. So x should be greater than or equal to okay, so 2 kilometer, so 2 into 10 cube meter by 10 power 8 meter into 10 power 7 bits. So now I have got 2 into 10 raised to 10 divided by 10 raised to 8. This is 200 bits. So dear friends, I have got 200 bits. So don't be in hurry. You have to be attentive. The options, if you check, they are in the bytes. So we know x must be greater than or equal to 200 bits. That means in bytes if you calculate, x must be greater than or equal to 25 bytes. Do we have 25 here? No. So the answer should be D, none. Don't think none can't be the answer. Of course, very rarely it would be, but none also will be the answer, dear friends. Just because you got 200, if you are not worried about the units, guys, you will select C, isn't it? So you have to be very attentive. Okay? Okay, dear friends, Kaustub, Anita, Nishu, Devika, everybody, please respond. All the others. Anita, sir, part 1 session, very nice and useful. Thank you, Anita. Great. Now, let's see this question, 2005 gate question. Again, you have to find out the minimum frame size. So, do it quickly. Let's see who will give the correct answer first. Quick. We are given CSMA CD. So, definitely you can apply TD greater than or equal to 2PD formula. We are given 1 gigabit per second bandwidth, 1 kilometer cable, speed. So, frame size, let it be x. X must be greater than or equal to 2 into length by speed into bandwidth 1 gigabits per second. So Kaustubh, here you see, we know giga is equal to, like 1k is equal to 2 power 10, you can approximate it to 10 cube. 1 mega is 2 power 20, approximate to 10 power 6. 1 giga is 2 power 30, actually you can approximate to 10 raised to 9, because we require here approximately. So x must be greater than or equal to per second got cancelled. So you see here 1 kilometer means 1 into 10 cube meters by 10 power 8 meters into 1 giga 10 power 9 bits. So x must be greater than or equal to 10 raised to 12 by meter got cancelled, 10 raised to 8. So x must be greater than or equal to what we have left, bits. 10 raised to 4 bits. That means 10,000 bits. But options are, you see, 10,000 bytes, 10,000 bits. Both are in the options. So if you are not concentrated enough, you might select the wrong option, right? So please mind, the minimum frame size should be 10,000 bits or more. So option A is the right answer here. Everybody understood? Are we clear, guys? Great. Next, 2012 GATE question. You see, you have got so much information, but nowhere in the question you will find Ethernet, CSMA CD or 802.3 terms. If you want, you can check it out. So here you can't apply TD greater than or equal to 2PD formula. That is applicable for the network that follow that standard, that follow the technology. Anita, yes, it is 1250 bytes, but we don't have 1250 bytes in the answer beta, in the options beta. So it is 10,000 bits only. Okay. So what is the question? Consider the source computer, yes, transmitting the file of size 10 power 6 bits to the destination D over two routers R1, R2, three links L1, L2, L3. L1 connects S to R1, L2, R1 to R2, L3, R2 to D. So we have S, R1, R2, D. L1 connects S to R1, L2 connects R1 to R2, L3 connects R2 to D. Let each link be of length 100 km. So each link length is 100 km. Okay. Then assume signal travel over each link at speed 10 power 8 meter per second. Signal speed is 10 power 8 meter per second in all the links. Bandwidth is given 1 megabit per second in all the links. Let the file is broken down into 1000 packets of size 1000 bits. So 10 power 6 bit file divided into 10 cube partitions. 10 cube partitions. So obviously 10 power 6 by 10 cube would be 10 cube only, no? So each partition size is 1000 bits. Okay. Now what you want? Find the total sum of transmission delay and propagation delay in transmitting the file from source to destination. Now, do we have single packet? No, we have 1000 packets, dear friends. So how do we calculate? Actually, we use pipelining technique, we say. But if you remember, already while discussing the formulae, I have given a formulae series. I have given one simple formula, dear friends, to calculate these kind of questions. There may be 1000 packets, 5000 packets, 10,000 packets. There may be two routers in between, 100 intermediate nodes, 1000 intermediate nodes. Let it be. And each link length, bandwidth, everything is given same here, but they can be different also. Let it be. So whatever may be the complexity in this model question, I have given one simple formula, if you remember. What is that? Let n be the number of packets. Okay? Let n be the number of packets, total number of packets to transmit. If so, the total time for n packets is equal to, the total time for n packets is equal to total time for one packet, total time for one packet plus all remaining n packets transmission delay. If you count, you will get the total time, dear friends. Why? Until first packet transmission is over, remaining packets are waiting. Once first packet transmission is over, once it is propagating, okay, it is propagating to destination or intermediate node, that is okay. But at the same time, second packet processing started. Second packet started its transmission. Once second packet is propagating, third packet transmission starts. So all the time, when you see the time, all the packets are active. Got it? So every packet wait only until its previous packet transmission is over. So that is only the time any packet will wait. So that is how here Tn is the total time for n packets. Total time for n packets. T1 is the total time for one packet. And Tt is the transmission time of n-1 packets. Here in our question, n is 1000, number of packets is 1000. Now we have source, in between we have router 1, router 2, destination. Okay. Now the length of each cable is 100 kilometers. Given. Speed is 10 power 8 meters per second. Bandwidth is 1 megabit per second. Packet size is 1000 bits. So now let us calculate transmission delay. So here it will be transmitting. So what is transmission delay at source? 1000 divided by 10 power 1 megabit means I am directly writing 10 power 6 bits per second. So this is 10 cube seconds, 10 power minus 3 seconds. So this is 1 millisecond. Where at S. Now it reach R1. We will calculate what is the propagation delay. At R1 also it has to be loaded, right? So at R1, same bandwidth, same packet. Then at R1 Tt, you will get same 1 millisecond. Then at R2 also the same bandwidth, same packet. So you will get the same 1 millisecond. So what is the total transmission delay for one packet? 3 milliseconds. Okay. Now S to R1, what is the propagation delay? Length by speed. Length 100 kilometer, speed 10 power 8 meters per second. So 100 I can write as 10 cube meter, 100 kilometer as divided by 10 power 8 meters per second. So this is 10 power 5 by 10 power 8, again 10 power minus 3 second, that is 1 millisecond. Now what is the propagation delay from R1 to R2? Same length, same speed. R2 to destination, same length, same speed. So this would be same 3 millisecond. Now you tell me what is the total time for one packet? 3 plus 3, 6 millisecond. है ना? So now you calculate what is the total time for 1000 packets. That is 6 plus remaining packets, 1000 minus 1. And what is the transmission delay? What is TT? TT doesn't mean total 3 millisecond. TT at source, guys, this is at source. So what is that? 1 millisecond. So this is 6 plus 999 into 1, 1005 milliseconds. So that is the answer, dear friends. Got it? Am I clear? Guys, you use this formula for any complex question. This works. Okay, Anita, Kaustub, Nishu, everybody. So the answer for this is 1005 milliseconds. Okay. So guys, now you people can get our free ebook and information about scholarship test, when it is conducting, how much scholarship you get, and also all the notifications, info about our free GATE workshops together. If you subscribe to our channel, link will be in the description. So do subscribe and register for our workshops, scholarship tests. Okay. Now guys, delays part over. Now error control. We know error control is majorly the functionality of data link layer, which is layer 2. That is the reason why data link layer add tailor. So where this error handling information it keep in the tailor. When you call it as error, when the transmitted and received are not same, then you say error. Not same means there can be many reasons. Something more added, something removed, or modified, keeping the length same, modification. In any way you say it is error, right? This error you call as two types. One is a single bit error, other burst error. Single bit error, when there is a change in transmitted data and received data in only one bit, that is single bit. If more than one bit change, burst. Now to handle these errors, we have two types of techniques: error detection and correction. What is the difference between this? Detection only find the presence, error high, yeah, nahi. But it can't tell you what is error, which bit is error, where is the error. Just it will tell you whether error is there or not. But detection and correction will tell you not only presence but also position. What are different detection codes? What are different detection codes? Vertical redundancy check, longitudinal redundancy check, cyclic redundancy check, and checksum. These four are popular detection codes, and Hamming code is detection and correction code, dear friends. Right? So among these, CRC, Hamming code, these two are very important for our GATE exam. VRC is like parity, guys. Vertical redundancy check is parity, simple parity mechanism, where you can have even parity or odd parity, means making number of ones even or number of ones odd. Longitudinal redundancy check you call as block parity, but both have the drawbacks. Both have the drawbacks, means when there are even number of ones When there is 1 error, 3 errors, 5 errors, you will be able to find out. But when there are 2 errors, 2-bit change, 4-bit change, 6-bit change, even number of bit errors are there, they will not be able to find out. That's why VRC, LRC we don't. Then CRC, cyclic redundancy check, what it is? It is basically based on the division process. What we do, what happens in this CRC means division process. Division means we know we will have divisor, we divide dividend with divisor, you will have quotient and remainder. These are the 4 values in the division process, right? Here, before the division starts, what sender do is, if the divisor is of n bits, if the divisor is of n bits, he will keep n minus 1 zeros at the end of the dividend. Means n minus 1 zeros are appended to the dividend and perform division. So you will get some remainder. Then replace this remainder and send. When the receiver receives it, receiver also follow the same procedure. He will use the same divisor. He will divide that received word with the same divisor. What he should get? If he get 0 remainder, that means no error is present. Non-zero remainder, it can be any. Non-zero remainder, that means error is present. This is what the CRC procedure, guys. Let's see an example before that. In CRC, the divisor is shared represented in the polynomial form, not in binary. For example, if the divisor is 1101, that is represented as x cube plus x square plus 1. X cube means 1 into x cube, 1 into x square. There is no x power 1th term. So 0 into x power 1 plus 1 into x power 0. So you take the coefficients of these x terms. So that is how it is 1101. Okay. Now let's see the example. We are given 1001 is the divisor and this is the data you have to transmit. So find out the CRC remainder, or sometimes you will be asked what is the code word. Code word means what you transmit is called code word. Means after appending the CRC remainder. Okay, let us do it. So everybody do it along with me. So 1101, 10101 is the dividend given. Now you see the divisor, it is having 4 bits. So append 3 zeros. Okay, 3 zeros. Start division. Division means what you have to do? It is actually XOR operation. So do XOR 0 1 0 0. When the MSB is 0, you shift left. Means you can say simply neglect and borrow the next bit from the dividend. 1001. We got all zeros when you do XOR. Now, actual algorithm run by shifting one bit, by neglecting one bit, just to save the time. You can do 4 shifts at a time, but be careful, make sure you have 4 bits to borrow. Okay, actually you can't do that multiple bit shifting at a time. Just to save the time, you can do that in the exam. Before that, make sure you have those many bits to borrow. So I am shifting all these bits, shift left and borrow all these bits. So 0 1 0 1. Now do XOR 1 1 0 0. When MSB is 0, you are simply shifting left so that it is discarded. But when MSB is 1, you can't simply discard it, no? So when MSB is 1, do XOR again. So 1 0 0 1. So this would be 0 1 0 1. Shift left, borrow the bit. Do XOR 1 0 0 1. So this is 0 0 1 1. Now I have 2 MSB zeros. Can I shift at a time? Do I have 2 zeros to borrow? Yes. So do shift all these 2 and borrow 2 bits together. So it is 1 0 0 1 0 1 0 0. Now MSB is 0. Shift left. Now when you look to borrow, there is no bit to borrow. So here it ends. So what is the CRC reminder? 1 0 0. So what is the code word you say? Data word followed by CRC reminder. Understood everyone? Understood everyone or not? Yeah. Sorry. It is 1 0 1. One 0 1. When you do 0 1 XOR, it would be 1 0 1. Everyone understood the procedure? If so, everybody do this 2005 GATE question guys. फटाफट कर लेना बेटा, फटाफट करके जवाब दो. Two 2005 GATE question. We are given the message to be transmitted and the CRC divisor is x power 5 plus x power 4 plus x square plus 1. If so, what is the remainder? You want remainder. Sanidas, sir, I completed C, DS, Algo, DBMS. Okay, very good. Is it possible to get 50 plus within the remaining days? I can put 8 hours per day. Sanidas, what about mathematics, engineering maths, discrete maths, apti part? Are they done or to be done? Definitely not just 50 plus, even 60 plus also possible, as you can give 8 hours per day. Sanidas, just recently I have done a session how you can be under 100 in 100 days preparation. Just few days ago, last week only I have done it in our website, in our YouTube channel. If you go through, you will get it. Please refer that. There I have explained how you can do it. Okay, definitely possible, Sanidas. But make sure engineering maths, discrete maths and your apti are clear with, you are doing them, because you can't skip them, because they together is 28 marks out of 100, 28 marks from them only. So definitely you have to pick those. So no problem, you can give 20 days time for those 3, that's okay, as you are already done with 4 subjects. So make sure those 3 are also completed: engineering maths, discrete maths, apti. So 7 will be completed, and in the rest 2 months time you can go with 2 months, means you should not prepare 2 months, make sure just 40 days, 45 days, because the last 15 days you should leave for the revision and mock tests. So in the 45 days you can prepare more 2-3 subjects. So definitely it works out. Okay, for better idea, please refer that session last week I have done, how you can attain, how you can be under 100 in 100 days preparation. Okay, fine. So guys, what is the answer for this? 101001101 is the message, and x power 5 plus x power 4 plus x square plus 1, if you convert into binary, 1 into x cube not there, so 0, 1 into x square, 1 into x power 1 is not there, so 0, 1. So 110101, do XOR before that, as it is having 6 zeros, append 6 bits in the divisor, append 5 zeros. So 110101, you get 011101. So I discard this and I borrow this 110101. So 00111. So these 2 zeros I discard, straight away I borrowed these 2 bits. 110101, 001111. Again these 2 zeros I discard, and these 2 I borrow. 10. So 110101, again 001011, I borrow these 2 zeros. 110101, so I get 011001. So I just discard this 0 and borrow this 10, guys. So 110010, this is 0 I have borrowed here. 110101, 000111. Now I can't discard 3 zeros at a time, because I just have 1 0 only I have to borrow. So I borrow single 0 by discarding single 0 here. So 110101, it is 11111011. MSB is 1, so do XOR again. 110101, it is a 0011110, discard, and finally what is the reminder you got? 01110. So option A. Good, Kaustubh, very good, Anita. Got it? So guys, it's a similar question, 2007 GATE question. Everybody do it. I am giving it for your practice. If you have not done it, please do it. Now moving on to Hamming code. It is a detection and correction code, dear friends. That means it will not only tell you whether error is present or not, but also tell you which bit is error. Right? Now we know what you want to transmit, that is data word. What you transmit is code word. So what is the difference? For the data word, you will append redundant bits. Right? So what this Hamming code says. Kaustubh, last step necessary to do XOR again means I am doing XOR because the MSB was 1. As an algorithm, I am doing it. When MSB is 1, you can't shift left and stop, means the loop won't stop, no, the loop won't break. The loop gets break when there are no bits to borrow. So that is the break point for the loop. That's why. Okay. So what this Hamming code is different, how it is different means, if you see all the other techniques, they append redundant bits consecutively at one place, means at the last. But Hamming code will keep the redundant bits in between the data word, means it distribute, it scatter, it merge the redundant bits in between the data word here and there, where it will keep in the 2 power ith positions, means I starts with a 0, that means in the first position, I with 1, second position, I becomes 2, fourth position, 8th position, like that in those positions it will keep the redundant bits. Okay, in that way it is different. Now the sender don't know whether those redundant bits should be zeros or ones. So how he calculate those bits? So first write the bit positions from 1 to how many positions we have in the data word, write. Okay. Now mark all the bit positions that are powers of 2. Okay. Then all the other positions are for data. These positions are for the parity bits or these redundant bits. Now how we calculate each parity? Let us see. The first position bit you calculate. How? Check 1 bit, skip 1 bit. Check 1 bit, skip 1 bit. That means you do XOR between these position values. XOR. Now position 2. Check 2 bits, skip 2 bits, means you do second position, third position value, sixth position, seventh position value, and so on. Like this, position 4, check 4 bits, skip 4 bits. Position 8, check 8 bits, skip 8 bits. Let's see what it means. Suppose this is what the data you wanted to transmit. Okay. Now give me a moment, guys. Suppose this is the data you want to transmit. Now you start from the LSB position. Okay. Here position numbering start from 1, not from 0 in Hamming code. Okay. First position is redundant bit position. Second position is redundant bit position. Third position is not redundant bit position. So place data bit. Fourth position is redundant bit position. So write it as R3. Fifth is not redundant bit position. So place data bit. Sixth is not redundant bit. So place data bit. Seventh also data position. Eighth is again redundant bit position. Ninth is data bit position. So 1. 10 is data bit position. So 0. 1 1 0 1 1 1 1 0. Now 11th is data bit position. So 1. 12th is redundant data bit position. 13th is 14th is 1. Okay. So this is how I have marked. So 1 1 0 1 0 1 1 1 0 1 0 1 1 0 1 1. Yep. So yes, I have done correct. Now how many positions I have? 14. So mark 14 binary values, 1 to 14. 1 0 0 0 1, 2 0 0 1 0, 3 0 0 1 1, 4 0 1 0 0, 5 0 1 0 1, 6 0 1 1 0, 7 0 1 1 1, 8 1 0 0 0, 9 1 0 0 1, 10 1 0 1 0, 11 1 0 1 1, 12 1 1 0 0, 13 1 1 0 1, 14 1 1 1 0. So what is this check 2 bit, skip 2 bit? All that means, if you don't understand the terminology, do this. I want R1. R1 means the first position. So first position is having 1 in the LSB. What other have 1 in the LSB? Third position, 5th, 7, 9, 11, 13. So we want to find out R1. Leaving that position, remaining all position bits do XOR. Okay. So third position bit, fifth position bit, seventh position bit, ninth position bit, 11th position bit, 13th position bit. What I have in third position? 1. Fifth position 1, 7 1, 9 1, 11 1, 13 1. So how do you do XOR? XOR says, when there are even number of ones, output 0, odd number of ones, output 1. So count number of ones, 1, 2, 3, 4, 5, 6, even number of ones. So 0. R1 is 0. So replace R1 with 0. Now how do I get R2? R2 is what? Second position. So in the second position, I have 1 in this 10th place. So what other have ones in the 10th place? Check it. 3, 6, 7, 10, 11, 14. So this is what? Check 2, skip 2. Check 2, skip 2. Check 2, skip 2. That is what? So okay, so I want R2, which is the second position value, so we skip it, means excluding that, remaining all you include and do XOR. That means third position, 6th, 7th, 10, 11 and 14. Third position 1, 6th position 0, 7th 1, 10th 0, 11th 1, 14th 1. So count number of ones, 1, 2, 3, 4, even number, so it would be 0. So R2 is 0, right? Now what is R3? R3 is in the fourth position beta. So check the binary value of 4. I have 1 in the hundreds place, right? So what other have ones in the hundreds place? Check it. 4, 5, 6, 7, 12, 13, 14. So excluding that 4, include all the other. So 5, 6, 7, 12, not 12, 10, 12, 10 है, 10 नहीं है, 12, 13, 14. So 5 is what? 1. XOR. 6 is what? 0. 7 is what? 1. 12 is what? 0. 13, 1. 14, 1. So count number of ones. Again even. So 0. Now finally R4. R4 is the 8th position bit. Sorry. R3. R4 is the 8th position bit. So 8th position, if you see, MSB 1 is there. So what other have MSB 1s? You check it. From 8 till 14 all have MSB 1s. So exclude 8 and include all the other. So 9, 10, 11, 12, 13, 14. So 9, 1, 10, 0, 11, 1, 0, 1, 1. 1, 0, 1, 0, 1, 1. So I got even number of ones. So again 0. So all redundant bits are zeros for this example. You don't get 0 for every example. Based on the data it would be. Now what happens? Now you are replacing those R's with zeros, sending. Receiver follow the same procedure, but here we excluded R1, means 1, 2, 4, 8 positions, no, while calculating. Receiver include them and do XOR. He should not get any R as 0. If he get any redundant bit value non-zero, that means error is present. Okay. So how the receiver confirm that error is present? Receiver confirm that error at R1, R2, R3, R4, any R's you have in this way at that position. So if there are no errors, RRs will be zeros. When RRs are zeros, it says at 0th position. That's why I said don't count from 0, count from 1. Now you might have understood. Okay. Now about Hamming code, one more important point we can understand or we have to recall is Hamming distance. What Hamming distance is? The number of differences you find, number of bit errors you find in the code word is Hamming distance. if you want to detect D errors, the minimum Hamming distance should be D plus 1. If you want to correct the same D number of errors, the minimum Hamming distance should be 2D plus 1. Okay, now I am not explaining how it is and all, but I am just recalling it, reminding about this. So it is very important point, please do remember. Okay guys, so this is what quick recap of delays and error control from computer networks, the first topic. The next topic, sliding window protocols, which is tomorrow at 8:30 p.m. I hope this session has revised delays and error control topic quickly in an effective way. Yes? Please do respond guys. So we will discuss sliding window protocols, very important topic, tomorrow sharp at 8:30. Now our test series are at affordable prices guys. So visit our BYJU'S Exam Prep app or website to know the details. This is my Telegram group link. If you want to connect with me, please do join my Telegram group. Thank you so much for joining the session, dear friends. I wish you all a very happy learning. Thank you so much for joining. See you in the next session. Till then, have a great time. Take care everybody. Good night. Bye-bye.